Hello friends, welcome back to my YouTube channel. So in today's video we will solve a problem of frame. How to analyze this by using the unit load method. So this is the given problem. So find the horizontal displacement of roller support by using unit load method and take E is equal to 200 GPa and I is equal to 4 into 10 to the power of 8 mm to the power of 4. So this is our given problem. The first thing what we have to do is we have to calculate the support reactions of this in support and this roller support. And at in support the possible reaction will be one is horizontal and another is vertical, VA and HA. And at roller support only one reaction takes place, that is vertical, call it as V. So now we need to find this reaction. So summation of moment about A is equal to 0. Clockwise we need to take positive. So here UDL is there. 10 into at what distance it is acting? It is acting at a distance of 5 meter. 10 into 5. So 10 into 5 into it always act at the distance of L divided by 2. L divided by 2 is nothing but half of the distance. So here total distance is 5 meter. 5 meter means from here to here is 2.5 and here to here is 2.5. So it becomes 2.5. So 10 into 5 into 2.5. So it rotates clockwise. Plus 1. Point load is acting here 20 kilonewton at a distance of 2 meter. It is also moving clockwise. So 20 into 2 minus V is, so V is rotating anti-clockwise, so minus V into at a distance of 5 meter. So V into 5 meter, we need to take the perpendicular distance now. So V into 5 meter. V into 5 is equal to 0. So now solve it. 10 into 5 into 2.5 plus 20 into 2 minus V is nothing but our X. X into 5 is equal to 0. So our V come out as 33. Write it here. V is equal to 33. It is moving upward. 33. Similarly for summation of all the vertical forces is equal to 0. Upward we need to take the positive. Here VA and V is moving upward, so take the positive. VA plus V value we got was 33 minus here on point load is there 20 is equal to 0. So solve it. VA is equal, it will come out as minus 13 kilonewton. So it is downward. So whatever the direction we have taken was opposite, so we need to make it as downward. So we need to correct it. So I will correct it. VA is downward. I will write it here. VA is downward. So it is 13. Similarly for summation of all the horizontal forces is equal to 0. We need to take right to left positive. So here on point load is moving, so UDL is there. If you convert it into point load, so it acts like this, horizontal. So 10 into 5, 10 into 5 is nothing but 50, it becomes 50. So it acts like this. So like this means left to right, it means positive. So 10 into 5 is equal to 50, it becomes 50. So that's why 50 minus HA is moving right to left. So minus HA is equal to 0. Solve it. Our HA will come out as 50. So 50 means whatever the direction we have taken was correct. So HA is 50. This is how we need to find all the support reaction. They say to find out the horizontal displacement of roller support. It means we need to apply the unit load of 1 kilonewton at roller support. So we need to redraw the diagram by removing all the external loads. So I will draw it. This is our redrawn diagram. Here at point E we need to apply the unit load of 1 kilonewton. So unit load of 1 kilonewton. So they say to find the horizontal displacement at point E. So that's why we need to apply the unit load of 1 kilonewton at support E. So now what we have to do is we need to calculate the support reaction for this also. Here in support is there, it means one HA will takes place and VA is takes place. Here also roller is there, V is takes place. So there is no any vertical forces here in this. So our summation of Fy is equal to 0. So there is no vertical forces, no. So that's why our VA also becomes 0, VE also becomes 0. So here one horizontal is there, so it is coming in this direction, no? I will tell you. So summation of all the horizontal forces is equal to 0. Left to right we need to take the positive. Here it is moving left to right 1 kilonewton. So 1 plus it is also moving left to right, no? That's why HA, it is also positive, is equal to 0. So HA will come out as minus 1. Minus 1 means the whatever the direction we have taken is wrong. It is moving in this direction. It is moving in this direction. So make it is moving in this direction. It has the intensity of 1 kilonewton. This is our HA value. So this is how we need to find the support reaction of this diagram. It is called as the M1 and it is called as capital M. So M is nothing but moment of our actual diagram, and here M1 is nothing but our moment of whatever the unit load we have applied at joint E. Moment of this we need to find. We have find the support reaction of both the diagram. So next what we have to do is we need to draw a table. I will show you. This is the diagram. Here M is member. So whatever the member we have AB, BC and CD and DE. So we need to write it here. AB, BC, CD and DE. For AB I am taking the origin as A. For BC I am taking the origin as B. For CD I am taking the origin as D, and for DE I am taking the origin as E. And limit of AB is, so AB we have the distance 5 meter, no? Our limit will be 0 to 5. For BC we have the length 2 meter, so our limit becomes 0 to 2. For CD we have the distance 3 meter, so limit becomes 0 to 3. For DE we have the distance 5 meter, limit becomes 0 to 5. So now for capital M for AB. So here we need to cut the section away from the origin A. For AB I am taking the origin as A. Now we need to cut the section away from this origin. It means we need to, our section will come here, x-axis, at a distance of x from the origin A. So now whatever the reactions are there here, so here horizontal load is moving upward, which is moving upward we need to take positive, and which is moving downward we need to take minus, negative. So HA is moving upward, so we need to take the positive. At what distance from this section it is moving? It is moving at a distance of x from here to here. So it means 50 into x. So write it here, 50 into x. So here UDL is also acting. At what distance it is acting? So it has the intensity of 10. So 10 into at a distance of x it is acting. So 10 into x. UDL always act at a distance of L divided by 2. L is nothing but our length. Our length is here x, no? So x divided by 2. 2 1 2 5. So it becomes 5x square. So it comes downward. Now we need to take the negative which is moving downward. So minus 5x square. So minus 5x square. So similarly for M1 we have taken the origin as A. It means we need to cut the section x-axis here away from the origin A at a distance of x. Here 1 kilonewton is moving, so it is moving upward, we need to take the positive. So at what distance from this section it is moving at a distance of x, so 1 into x. So m1 will be 1 into x is nothing but x. Ei value I will write it later. And for BC I have taken the origin as B. It means we need to cut the section x-axis here away from the origin B at a distance of x. So now we need to solve from here to here, here to here. So here HA is moving, it is moving upward. Upward means we need to take the positive. So 50 into at what distance it is moving, we need to see the perpendicular distance. So perpendicular distance of HA is 5 meters. So 50 into 5. 50 into 5. So I will write it here. 50 into 5. So here VA is also acting, it is moving downward. It means we need to take the negative which is moving downward. So VA into the perpendicular distance is x. Perpendicular distance is x for VA, perpendicular distance is x. So VA into x minus VA into x. So VA has the intensity of 13. So 13 into x. So minus 13 into x. And here one more load is there, that is UDL is acting. So 10 into at a distance of 5. So UDL always act at a distance of L by 2. L by 2 means our here to here 5 means here to here because 2.5. Half of this is means 2.5. So 10 into 5 into 2.5 minus 10 into 5 into 2.5. So now solve it. It will come out as 125 minus 13x. So now write it here. 125 minus 13x. Similarly for M1, if you cut the section for BC, if you cut the section x-axis away from the origin B at a distance of x, so 1 kilonewton is acting at what distance from here to here is, it is acting at a distance of the, we need to see the perpendicular distance. So for H our perpendicular distance is 5 meter. So 1 into 5 becomes 5. Sorry, M1 will be 5. Similarly for CD, we have taken the origin as D. For CD, I have taken the origin as D. It means our section will come here, x-axis at a distance of x. So here VE is moving. So at what distance it is moving, we need to see the always perpendicular distance. So perpendicular distance of V is x. So it is also moving upward. It means we need to take the positive. So V into x. So V has an intensity of 33. 33 into x. Our answer will come 33 into x. See here why for CD I have taken origin as D means, see here. So I have taken origin as D means we need to solve from here to here. Here we have only one load at this part. If you take the origin as C, then our section will come here. We need to solve from here to here. Our calculation becomes lengthy. So while calculating the moment in this unit plot method, we have the two choice. You can solve from this side or from this side. It depends on taking the origin. You can take whatever you want. For easy calculation, I am taking the origin as D. Our section will come here because here we have only one load. No, it is easy to calculation. That's why I have taken origin as D. So CDM becomes 33x. If you cut the section x-axis away from the origin D at a distance of x, so here 1 kilonewton is moving upward. So at what distance from this section it is moving, we need to see the perpendicular distance. For 1 kilonewton, this is the perpendicular. So 1 into 5, perpendicular distance is 5 meters. So 1 into 5 will be 5. So write it here. Now for D, have taken the origin as E. Our section will come here away from the origin E at a distance of x. So here V is moving axial to this. Now the perpendicular distance becomes 0. So 0 into anything becomes 0. So for member D, we have the moment value 0 because there is no distance. Distance is 0. It becomes 0. Similarly for M1, if you cut the section x-axis away from the origin E, at a distance of x. So 1 kilonewton at what distance it is acting from this section is it is acting at a distance of x. For 1 kilonewton the perpendicular distance becomes x. So 1 into x is nothing but x. It is also moving upward. We need to take the positive. 1 into x is nothing but x. So now we have calculated the moment for all the members. This is how we need to find the moment for each member. So now next what we have to do is we need to find the deflection. We have the formula YD. To find the deflection we have the formula integration of 0 to L capital M small m divided by EI into dx. So now we need to put all the value. I am taking 1 divided by EI outside. I will put it later. So integration of for AB member we have the limit 0 to 5. Integration of 0 to 5 this into this. So 50x minus 5x square into x plus integration of for BC we have the limit 0 to 2, 0 to 2 this into this. 125 minus 13x into 5 dx plus integration of for CD member we have the limit 0 to 3 this into this. 33x into 5 dx into dx. And for DE we have the value 0 here. 0 into anything becomes 0, so I am not taking it. So now solve it. Integration of 0 to 5 into 50x minus 5x square close the bracket and again bracket x close the bracket plus integration of this one plus integration of 0 to 2 into 125 minus 13x close the bracket 5 plus integration of 0 to 3 into 33 into x into 5. So now solve it. Our YD deflection value will come out as 3064.58. So write it here 164.58 divided by EI. So see here our E value is given was 200 GPa and I value is 4 into 10 to the power of 8 mm to the power of 4. We need to convert this into meter, both into meter. To find out the deflection always we have to put the value in meter only. So now we need to convert 200 GPa into meter and 4 into 10 to the power of 8 mm to the power of 4 into meter. We need to convert it. I will show you how to convert. To convert this into Newton per mm square we need to multiply 10 to the power of 3. So Newton per mm square. So to convert 200 into kilonewton per meter square we need to multiply again 10 to the power of 3 into 10 to the power of 3 kilonewton per meter square. So it becomes 200 into 10 to the power of 6 kilonewton per meter square. Similarly to convert this into meters we need to multiply 4 into 10 to the power of 8 into 10 to the power of minus 12. So it becomes 4 into 10 to the power of minus 4 m to the power of 4. So now we need to substitute these two value in here. 3164.58 divided by E value is 200, I value is 4. Here 10 to the power of 6 and 10 to the power of minus 4 becomes 10 to the power of 2. So now solve it. It will come out as 0.039 meter. This is nothing but our deflection value. This is nothing but our deflection value. This is how we need to find the horizontal displacement. And I hope you all are understood this sign convention. So here our problem ends. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.